Hello and welcome to another episode of the Mitsubishi Electric Mastered Series. Today we'll take a look at setting up parameters using our NC Configurator2 software for the M80V control. I'm Matt Basque with Mitsubishi Electric Automation, and let's get started. When we start NC Configurator 2, we'll get an initial pop-up screen that gives us a couple different options. We're going to select a new since we're creating a new project here. The next pop-up screen gives us several different options to select from. The first one being the NC type. Most of these boxes have a drop-down menu. We're going to set up an M80V, so we'll make that selection here. The system type gives us an option between mill and lathe. We're going to set up a simple mill here. The language gives us 17 different options, the default being English, so we'll leave that there. The unit type is metric or inch. This is the internal parameter settings for the machine. This is not the position page or the G-code program. Those are dictated by a separate parameter. The next selection here under system settings, we can select how many axes we have as well as spindles. We can also add in additional systems by adding axis into those, as well as adding in PLC axis. We're going to leave these as the default because we're going to set this up as a simple 3-axis machining center with a spindle. The command type here is the position page and how many decimal places we're going to display, as well as what we're utilizing inside of our G-code program. The control unit is the decimal places that the internal calculations of the software will use, as well as the positioning control that's going to be sent out to our servo system. So again, we'll leave this as a default. For the command type, we're going to actually choose the second selection here, and this has to do with our tool offsets, being that the first selection only gives us a single value for each one of our tool offsets. The second setting here gives us a length and a diameter and also adds wear columns to those there as well. Once we have all these selections here, we're going to select our next. The next screen gives us a bunch of information that is pulled from the previous screen. So you'll see our 3 servo system as well as our spindle here. So we have several different options that we need to make here. So the command name, this is going to be the command name coming from the G-code program. So we're going to command these as X, Y, and Z on our 3 servos. The display name has to do with the positioning that's shown on the monitor page. We can actually use 2 digits on this. So if you wanted to call this X1, Y1, Z1, you could do that. We'll leave this as the default. The rotary switch is an address setting for each one of our drives. Each drive has a specific rotary switch on it. And again, we'll leave this as the default on here. For the driver type, we're going to make a small change to this. We're going to choose our MDS EJV110 for each one of our drives. And once we make this selection, we need to select the motor type. There is only one motor that can run with these specific drives, so we will leave this as the default of the HG46. For the motor detector resolution, the auto setting is the only setting we can make, so we'll leave that as a default. For the regenerative resistor type for this specific drive, we can use the built-in resistor on this drive, or we can use an external optional resistor. We're going to leave this as the default built-in resistor. For emergency stop, there is a connection on the drive system that we can utilize. We're going to use this or leave this as invalid because we're going to utilize the emergency stop connection that's on our CNC control. For the contactor control, again, there is a connector on the drive that we can control an external contactor that will control the 3-phase voltage going to the drive system. Again, we're going to leave this as the default invalid. And last but not least is our synchronous control. And this is if I utilized 2 servo systems, so 2 servos, 2 motors that would control one axis and they would be synchronized together. Again, we'll leave this as the default invalid. Next, we're going to click on advanced settings here and make some additional options for our drive system. So we can see that some of the information that was pulled from the previous screen being our drive type, as well as the motor type. And then we can start selecting the axis. So we have a selection between linear or rotary. Again, we're going to set up a simple 3-axis machining center. So we'll leave these all at linear. We can make a gear ratio change for each one of these as well. We're going to assume that our machine is a 1-to-1 gear ratio, but we can make a change on this later if we needed to. The ball screw pitch, we're going to leave this as the default, a 10mm pitch. And the position control method, we have a choice between incremental and absolute. I'm actually going to make a change to this and make this absolute. Just know if you leave this as incremental, you have to add in a 0-turn dog switch and the machine will have to be zeroed out every time it is powered off and back on. For the absolute position detection method, we're going to make a change here. We're going to go to a marked point to method. And this is just two mark points that we're going to align together to create our home position. We're going to make the next selection up here, which is acceleration, deceleration, the tab up top here. And this is where we can make some changes to our speeds. So we can make a change to the rapid speeds as well as our cutting feed rate speeds. So I'm going to make a change to this, make this 3000 millimeters per minute for my rapid. And you can see I can make a change for my cutting feed rate. This is my G1, G2, G3. This is the maximum speed that we're going to allow this machine to run at. We can also change the acceleration deceleration type that we're going to use, and we're going to leave this as linear to linear, and you can see that we can make that selection between the rapid and the G1 or the cutting feed, and we can change the time constants here as well. We're going to leave these as the default. Lastly, there's the machine side detector, and this allows us to add in a linear or rotary scale to the system. We're going to leave this as no connection here, and we're going to select the finish down at the bottom. Next, we're going to select the type of spindle system that we have here, and you'll see that this drop-down menu gives us a selection between a Mitsubishi driver as well as inverter 1, 2, and 3. These would be if you were going to run your spindle with a VFD or analog driven drive. We're going to leave this as a Mitsubishi driver. You'll see some similar settings here. So the rotary switch setting, we're going to leave that at the default here. We're going to change the driver type, and we'll choose a similar drive, an MDS EJ SP100. And we'll select the first motor that's here again for this example. For the regenerative resistor, it's a bit different on this. You'll notice there is no built-in. We need to use an external regen. We'll just make the first selection here. Same thing goes for the external emergency stop with the servo system. We're going to leave this as invalid, as well as the contactor control, leave that invalid as well. And under spindle C axis, we're going to leave this as invalid. If I had a lathe here and I wanted to use this spindle as a C axis, I could actually match this with one of the servo systems up top here. And again, this spindle drive would act both as a speed device and a position device. Once we have all these selections, we'll select next down at the bottom. And this will give us a screen that gives us all of the selections that we made in the previous screens. We're going to select finish on this. And the system will basically create the parameter file based off of all of our selections that are there. The next screen that pops up asks for some basic information. This is optional and will be tied to the project, but not to the parameter file. So we can put some information here really quickly. Once we've input this data, we can save this project. Once the project is saved, now we want to set these parameters to our CNC. And there's two different ways we can do that. We can use the communication tab up here, and we can write these to the CNC, but we need our PC to be connected up to the CNC via an Ethernet cable and have our IP addresses set correctly. I do not have that set up right now, so we're going to go with option number 2, which is we're going to export the parameter data. By default, it's going to label it as all.prm, and that's pretty normal for our CNC to recognize that file type. We're going to send this out to our USB drive. Stay tuned for the next episode where we will load these newly created parameters into the CNC, as well as format the program memory area and set the time and date. And that concludes this video. Thanks for watching another episode of Mitsubishi Electric Mastered, where we show how quick and easy it is to become a master of Mitsubishi Electric industrial controls.